Hello students. Today we are going to see the expression for lateral displacement. So it will be easy only. So we know that what is lateral displacement. So once again for a quick recap I will say when I take a glass slab like this, okay, a glass slab like this, and a monochromatic light has fallen on this obliquely, okay, normal. Monochromatic, what is monochromatic, children? Mono means single, chromatic is color, so single color. The white color should not be passed, any single color can be passed, okay. So this is monochromatic light, and if I have to draw the original path over here, okay, original path, it should be going here in this way. If there is no glass slab but I have kept a glass slab over here, then it should bend, okay, and then it comes out like this, okay. So zig 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 it comes, no. So it has moved away from its path. This is the original path, but it has moved away from its path, correct. This point, this is what we call it as lateral displacement. Laterally, sidewise it has displaced, so we call it as lateral displacement. Clear? So let's take it as x. This distance, it should be perpendicular, don't forget that it should be perpendicular. Then we can draw it as 90 degree, and then this is the incident angle, correct. This is an incident angle, and then this is the refracted angle. One more thing, again this ray acts as the incident to this plane, this side. So this acts as the incident for this side, this acts as an incident for this side, correct. So if I have to draw the normal over here, one second, normal over here, correct. So here it acts as the I2, let's take it as I2, and this is R2, okay, R2, this is R1, I1, okay. Now one thing to notice, this angle, how can I write this angle? Can anybody think of it? This is I, and this can be zoomed and written as like this. This is the surface and the incident, and incident, and then the ray, correct. This is I1, correct, and this is R I said. We know that this line and this line, okay, this line and this line, don't consider this ray, take this and this, okay, we vertically opposite angles, okay. So this angle and this angle will be equal. So we can write as this to be I1 minus R1, correct. That is I1 minus R1, this angle. Again this surface, which angle, okay, like that only it happens, okay. This angle I have measured I1 minus R1, so you should keep that in mind. For explanation I have used crayons. I will draw this neatly in a sketch. Okay children, see this. Now these two triangles BFC is important, and BFC and BEC, okay. BFC, this triangle, and this triangle is important, okay. Now let's derive the expression, children. Now this triangle, in triangle BFC, in triangle BFC, what we have, BF by BC, BF by BC is cos R, this is R, correct. Then if we take this as cos, we know that cos is adjacent by hypotenuse. This is 90 degree. Then this acts as hypotenuse and this acts as an adjacent. So BF by BC is cos R. From this we can write BC to be BC as BF by cos R. Correct. Next is BF is this is the thickness of the glass slab. For simply, how can you understand? Now I have taken the sharpener as a glass slab. Okay, this is the thickness. Correct. This is the thickness of the glass slab. That's what I have taken here. This is the thickness of the glass slab. Like this, the compare this. This is the thickness. If I take this as to be T. Likewise, this glass slab also, this one is T. Okay. Now, then I can write BF to be T here. So, T by cos R. Clear? Next is X can be, what is X? This is X. X can be written as T cos R. Okay, T cos R sine I minus R. How will you say this? I told you, no, this triangle is also important. Here now this triangle plays an important role in triangle. Okay, in triangle BFC. So BEC X. This is opposite. If you take this angle, I already explained what is this angle. So sine I minus R, I1 minus R1 will be written as opposite EC, that is X by hypotenuse. This is 90 degree. I told you perpendicular shift only, no? So 90 degree, then hypotenuse. What is hypotenuse? BC. Then X can be written as BC sine I1 minus R1. Then here we can put this X, this BZ value over here. BZ, what is BC? This is what? Sine BC equals to X. Then BZ value is X by sine I by R1, correct? So BZ value is X by sine I1 minus R1. This has BC value T by cos R. Clear? Now if you take this, you will get this. Okay, children? Next is from Snell's law. Okay? Snell's law. Snell's law. What is Snell's law? We know the refraction is totally connected with Snell's law. Nu, refractive index, is sine I by sine R. Correct, children? Now, sine R can be written as sine I by nu. Correct? Now, you keep this as it is. Know that cos square R plus sine square R to be 1. Then how can we get cos R? We convert the terms. Cos R square is 1 minus sine square R. This root goes over here, square cancels. Now sine R. What is the sine R value? This one. Correct? So sine R can be written as root of 1 minus sine square I by nu. Again nu square. We got cos R value. Now it is we got cos R value. Note this value. Note these formulas clearly, children. Step by step, you should not get confused. Next is, this is first, and then here this continuation comes over here. This continuation. this continuation comes over here. Okay, now know that this formula x equals to t by cos r sin I minus r. Okay, this is in sin a minus b formula. Sin a minus b can be written as what? Sin a cos b minus cos a sin b. Correct? Trigonometry functions. Now, so how can you write this? T by cos r is sin, sorry, bracket, sin I cos r minus cos I sin r. Clear? Then we have to convert everything in terms of i's, that is incident angle forms. Then how can we convert easily? T by cos r, you multiply both inside. Okay, t by cos r, multiplying this, so sin I cos r by cos r minus cos I sin r by cos r. Then cos r cancels. Correct? Next it is what? How can we write? Sin I, keep it as it is in I form. R value we have found it to be sin I here, sin I by nu. Can we write this? T sin I minus sin R, sin I by nu. This cos R value to be we have found as this 1 minus sin I sin square I by nu square I. That will write here 1 minus sin square I by nu square half. That is root, no? Root we can write it as half. Clear, children? Got this? One more thing. Cos I have to write here cos I. Next it is conclusion formula only. That's it, we have completed. Okay, how to convert this? If so, this is the final formula what we have got. I will shade and highlight this. So this is the final formula. Okay, now if incident angle is maximum, that is sin I, when it is maximum, when the theta is 90 degree. So sin I is, if I is, if I is 90 degree, if I is 90 degree, then sin I will be maximum 1, then cos I will be 0. Correct? Then x max, that is maximum value only you are finding. Correct? Then sin I if it tends to 1, cos I if it tends to 0, then it becomes 0. Then the total displacement x will be what? T into sin 90. So the total thickness, this is the interesting case in physics, in this ray optics. How can you say x equals to t? The total lateral displacement will be equal to the thickness. That's what. So this can be your NEET question also. Okay, that time you have to think these things. And note this formula, children. In the next video we will see the refraction through a combination of medium. Okay, so you have to be clear with this concept. Okay, children, if you have any doubt, please comment in the comment section and subscribe our channel for more videos.